the 31st of January 1961. A Mercury capsule splashed into the Atlantic Ocean more than 250 miles off the coast of Florida. Recovery crews rushed toward it. The hatch swung open. Television cameras pointed straight inside. And what America saw was a smiling face. Ham, a 3'7" month old chimpanzee weighing less than 37 pounds, named after the Holloman Aerospace Medical Center, had just become the first American living creature to complete a controlled spaceflight. During the 16-minute mission, he pushed and released levers at precisely the right moments, responding to flashing lights exactly as he had been trained. To NASA engineers, those actions were proof that a human being could still perform precise manual tasks in the weightlessness of space. The photograph of Ham smiling after being lifted from the ocean, standing beside the recovery commander, appeared on newspaper front pages across the United States. It became a symbol of innocent courage, a perfect partnership between humanity and the most intelligent animal we had ever trained to serve our ambition of reaching the stars. 65 years later, primatologists looked at that same photograph with trained eyes and saw something entirely different. It was not a smile. In chimpanzee body language, exposing the teeth while pulling the lips tightly back across the face, the expression that the human brain, wired to recognize familiar patterns wherever it finds them, instinctively interprets as happiness, is known to behavioral scientists as a fear grimace. It is an intense alarm response, most commonly displayed when an individual is experiencing overwhelming physiological stress or facing a situation completely beyond its control. In other words, a flight through the upper atmosphere, a violent splashdown into the ocean, and a crowd of unfamiliar humans surrounding him with cameras is almost the perfect scenario for triggering extreme fear in any chimpanzee, no matter how well trained. America hung a photograph of overwhelming terror on its walls and called it a smile. That is, in many ways, exactly how we treated this species throughout more than half a century of popular media. We looked at the most expressive face in the primate world, a face equipped with nearly all the facial muscles found in humans, capable of producing dozens of subtle expressions, and we saw only what we wanted to see. We saw something cute. We saw something funny. We saw a furry little friend happily wearing jackets, helmets, and riding tricycles in television shows and commercials throughout the 1960s, 70s, and 80s. But Ham did not pilot a spacecraft because he wanted to help humanity conquer space. He pulled the correct levers because he had already endured hundreds of hours of training, during which every incorrect response was followed by a mild electric shock delivered to his feet. The brain controlling those remarkably dexterous hands, the same brain that will reappear later in this documentary under circumstances almost 50 years removed from this moment, was not operating out of loyalty or affection for human beings. It was operating through conditioned learning, the ability to calculate consequences, and a level of manual precision far beyond anything America's space program publicly acknowledged during the triumphant press conferences of 1961. You think you understand chimpanzees. You've seen them in soft drink commercials, amusement parks, and viral videos playing with their caretakers. But you've never seen what is truly happening inside those hands, or what they are capable of when the braking system inside that brain, the one we'll dissect in Part 3, stops working. To understand chimpanzees, you must first understand one fundamental fact. They do not live as a single, tightly packed herd, moving together like buffalo or elephants. They live in what primatologists call a Fission-Fusion Society, a social system that is constantly splitting apart and coming back together. A chimpanzee community may contain anywhere from 20 to 150 individuals occupying a shared territory. Yet almost never do all of them travel together at the same time. Instead, they continually divide into small parties, 3, 5, perhaps 10 animals that spread through different parts of the forest, searching for ripe fruit. Hours or days later, those same parties reunite at a common location, often a fruiting tree or an important water source. This is not an arbitrary social preference. It is evolution's mathematical solution to a very real survival problem. Fruit in the tropical forests of Central and West Africa is neither evenly distributed nor consistently available. It grows in scattered patches, ripens at different times depending on the season, the species of tree, and the local landscape. If 150 chimpanzees traveled everywhere as one massive group, they would strip a fruit tree bare within minutes, only to compete desperately for the next one. A strategy virtually guaranteed to produce recurring food shortages. So, natural selection favored something far more flexible. Split apart when food is scarce and scattered, reducing competition within the community. Come back together whenever a resource is large enough to share a giant fig tree bursting with ripe fruit, or a large prey animal, most often a red colobus monkey, to reinforce social bonds and, among males, display status and strengthen alliances. But this flexible social structure depends on one non-negotiable requirement: space. A chimpanzee community typically requires a territory ranging from roughly 2 to more than 20 square miles, depending on fruit abundance and seasonal availability. That space allows smaller parties to spread out without competing with one another and, just as importantly, without wandering into the territory of neighboring communities. This is not an abstract figure buried inside an ecological report. It is the minimum amount of living space required for survival, measured in calories and distance. 30 or 40 years ago, much of that territory still existed as uninterrupted forest, stretching across multiple countries. Today, it does not. The Western chimpanzee population alone has declined by more than 66% over the past 3 decades, according to data compiled by the International Union for Conservation of Nature. And forests rarely disappear by shrinking evenly inward from their edges. Instead, they are carved into isolated fragments like a map, torn into pieces by expanding agriculture, logging operations, and growing human settlements. When forests are fragmented this way, the fission-fusion system that evolution spent millions of years refining begins to break down in a very specific and predictable way. Small foraging parties no longer have enough room to spread out as they once did. They are forced to overlap with the feeding ranges of neighboring communities, the very kind of contact that the fission-fusion system evolved to minimize. In other words, when humans destroy a section of forest, we are not merely removing trees and food. We are dismantling the very mechanism that once helped keep the peace between neighboring chimpanzee communities. And when a chimpanzee community loses the ability to maintain a safe distance from its neighbors, it does not become gentler in order to adapt. It becomes more vigilant, more defensive. And, as part 5 of this documentary will demonstrate through one of the best documented events in the history of primatology, more willing to strike first. Most documentaries about chimpanzees stop at a familiar statistic. Chimpanzees are estimated to be 2 to 5 times stronger than an average adult human in pulling strength, thanks to a much higher proportion of fast-twitch muscle fibers, the fibers responsible for explosive bursts of power. That is true. And it is a genuine physical advantage. But it is not what makes chimpanzees truly terrifying at the deepest level. The truly frightening part lies within a tiny region of the brain, the primary motor cortex, the area responsible for controlling each individual finger. In most mammals, the amount of cortex devoted to controlling a body part is roughly proportional to that body's physical size. In chimpanzees, that rule breaks down at the hand. The portion of the brain dedicated to fine motor control of each finger is vastly larger than their body proportions. Alone can explain a neural map far closer to that of humans than any other non-human primate ever studied. The consequences of this neural hardware are not theoretical. They reveal themselves in one of the most sophisticated tool-making abilities ever documented outside our own species. Let's begin with the simpler example: termite fishing. A chimpanzee selects a specific twig from dozens nearby, strips away every leaf, sometimes sharpens the tip with its teeth, bends it several times to test its flexibility, and only then inserts it into a termite mound at exactly the right angle, allowing termites to cling to the stick before pulling it back out. Young chimpanzees learn this skill relatively early, typically around 4 years of age, simply by watching their mothers. But there is another technique, vastly more complex, that scientists regard as the pinnacle of chimpanzee tool use: cracking nuts with stone tools. This is the only known chimpanzee tool behavior requiring the coordinated use of 3 separate objects at the same time. A large stone serving as an anvil, another stone or heavy piece of wood functioning as a hammer, and the nut itself. These 3 objects almost never occur together naturally. The chimpanzee must carry both the hammer and the nuts to a location where a suitable anvil already exists, a behavior demonstrating planning that extends beyond the immediate moment. Unlike termite fishing, nutcracking does not produce an instant reward. The animal must strike repeatedly before the shell finally breaks open, meaning it must maintain motivation despite a delayed payoff rather than an immediate one. Archaeological evidence published in peer-reviewed scientific journals reveals something even more astonishing. In the Thai forest of Côte d'Ivoire, sediment layers containing stone fragments characteristic of chimpanzee nutcracking have been dated to more than 4,300 years ago. That means this technology has been passed continuously from one generation of chimpanzees to the next, in the same forest, since shortly after the Great Pyramid of Giza was completed. The same neural circuitry that makes this level of precision and persistence possible does not switch off when a chimpanzee moves from making tools to committing violence. It keeps working, with the same precision, the same ability to choose specific targets, the same capacity to adjust force in real time. To understand why that is genuinely alarming, compare chimpanzees with one of their closest relatives, a species so similar that for decades it was mistakenly called the pygmy chimpanzee, the bonobo. Genetically, bonobos and chimpanzees split from a common ancestor only about 2 million years ago, a mere blink on the evolutionary timescale. Physically, they are almost mirror images of one another. The same skeletal structure, the same black fur, the same long, climbing-adapted arms. To an untrained observer, placing the two species side by side makes them nearly impossible to distinguish without carefully examining leg proportions, skull shape, and lip coloration. But place their societies side by side, and you are looking at two completely different worlds. Chimpanzee society is fundamentally patriarchal. It is led by an alpha male who maintains his position through a network of alliances and, when necessary, through direct violence against rivals. Bonobo society is fundamentally matriarchal. Females form powerful alliances, often with individuals unrelated to them by blood, to collectively restrain aggression from individual males. While organized, lethal conflicts between neighboring chimpanzee communities have been documented repeatedly across multiple long-term field sites. Scientists have never reliably documented an organized intergroup killing among wild bonobos. The difference is not muscle. The two species are remarkably similar in physical strength and skeletal structure. The difference lies in the wiring inside the skull. Comparative brain imaging studies show that bonobos possess greater gray matter in regions associated with recognizing distress and anxiety in others, along with stronger neural connections between the amygdala, the brain's threat detection center, and the prefrontal cortex, the region responsible for impulse control and deliberate decision-making. In chimpanzees, those inhibitory pathways are significantly weaker. Put simply, bonobos possess a biological braking system that chimpanzees simply do not have to the same degree. The most dexterous hands in the non-human primate world, combined with a much weaker internal system for suppressing impulses than even their closest genetic relative. That is not the formula for a gentle animal that occasionally lashes out because of circumstance. It is the formula for a creature capable of carrying out violence with almost surgical precision, and with very little built-in restraint once that behavior has begun. The 16th of February 2009, Stamford, Connecticut. Travis, a male chimpanzee weighing roughly 200 pounds, had spent 14 years living as a member of a human family. He slept in a bed. He ate at the dinner table. He drank wine from a glass. He knew how to unlock doors inside the house. He knew how to use a tablet and a television remote. His owner, Sandra Harold, did not call him a pet. She called him her son. The neighbors knew his name. They waved when they saw him riding through town in the car beside Harold. He had appeared in television commercials, performing behaviors that made audiences laugh because of how remarkably human they seemed. To the surrounding community, Travis was living proof that a wild animal could be raised into something almost human. That afternoon, Sandra's close friend, Charla Nash, came to the house carrying a new handbag and wearing a hairstyle Travis had never seen before. Over the next 12 minutes, a span of time barely long enough to brew a pot of tea, Travis attacked her with the same hands that had spent 14 years holding wine glasses, tapping keyboards, opening locks, and waving to familiar faces. Warning: the following section contains descriptions of severe injuries that some viewers may find disturbing. He took both of Charla Nash's hands. He destroyed her nose, her lips, and both of her eyelids. The emergency responders, medical professionals who had witnessed countless scenes of violence throughout their careers, later admitted to the press that they could barely find the proper clinical language to describe what they saw. When they entered the house, the surgeons who treated her afterward did not describe the damage as ordinary wounds. In medical records and later interviews, they described something closer to the near-total removal of a human face from the skull beneath it. Charla Nash survived. She later underwent one of the very few full-face transplants ever performed in modern medical history, followed by years of rehabilitation. The most important thing to understand about the Stamford attack is not its brutality. The brutality was only the surface result. What matters is the pattern beneath it. Travis did not bite and tear at random like a panicked dog trapped in a corner. He targeted specific parts of the body: the face, the hands, the eyes, in a sequence that researchers studying chimpanzee-inflicted trauma have found to be disturbingly consistent across separate incidents in completely different locations. At primate research stations in Africa, inside suburban homes in the United States, and at primate sanctuaries where adult chimpanzees once kept as pets were transferred after their owners could no longer control them. This was the same hand we examined in Part 3, the hand backed by an unusually sophisticated region of motor cortex. And it was not operating in a state of total motor chaos. It was operating with full physical control, directed toward a clear objective, even if science still cannot say with certainty what that objective looked like inside the mind of an animal in a state of extreme agitation. The Stamford attack did not occur in isolation. As forests in Uganda, Guinea, and Cameroon continue to shrink and fragment through the same process, rural communities living near forest boundaries are reporting more encounters with wild chimpanzees, including cases in which chimpanzees approach human settlements. This type of information must be handled with extreme caution. Many reports circulate online as unverified anecdotes, sometimes naming victims or locations without any official source attached. For this script, such cases should be treated only as representative patterns, drawn from multiple published studies of human-chimpanzee conflict, not as independently verified incidents tied to a specific person whose identity cannot be confirmed. What can be stated carefully, based on decades of publicly available research into human-primate conflict across Africa, is this: many of these incidents do not resemble simple defensive attacks. They do not look like blind panic from an animal trapped with no escape. They show signs of deliberate approach, assessment before action, and selective execution. The very things this animal's hands and brain are built to do better than almost anything else, whether the target is a termite nest or a human being. Before the 1970s, scientists believed something with near absolute certainty. Organized warfare, the deliberate elimination of an opposing group over an extended period of time, was a behavior unique to humans. The person who shattered that belief was Jane Goodall, the primatologist who spent 65 years observing wild chimpanzees in Tanzania's Gombe National Park until her death in October 2025, leaving behind one of the longest continuous wildlife observation records in the history of science. In the mid-1970s, Goodall documented a sequence of events that would later become known as the Gombe Chimpanzee War. A single chimpanzee community, once living together, gradually split into two distinct factions, the northern group and the southern group. Over the next 4 years, the northern community systematically hunted down and killed nearly every adult member of the southern community, males, females, and even younger individuals, not through loud, open confrontations or dramatic displays of strength in broad daylight, but through carefully planned, silent raids. Small patrols of 3 to 6 males would move quietly toward the territorial boundary. They would stop, watch, listen, sometimes for several minutes. If they detected a lone chimpanzee from the rival community, they attacked together. Some restrained the victim. Others delivered the fatal blows with their hands, feet, and teeth. Then they withdrew into their own territory, leaving almost no trace until the body was discovered later. Subsequent studies conducted far beyond Gombe confirmed that this was not an isolated anomaly confined to one unusual population. A landmark analysis published in Nature in 2014 combined decades of long-term observations from 18 different chimpanzee communities. It found that lethal violence both within communities and between neighboring groups occurred at rates higher than those documented in most other mammal species studied using comparable methods. What makes this form of violence truly disturbing is not the brutality of the final attack. It is the planning that comes beforehand. Male chimpanzees patrol territorial borders in near-complete silence, a striking contrast to the noisy vocalizations that normally accompany their movements within familiar territory. They frequently stop to listen. If they detect signs that the opposing party outnumbers them, they retreat. If the numbers favor them, they advance. This is real-time risk assessment based on evaluating relative strength, not a simple, instinctive fight-or-flight response. The political structure within a chimpanzee community is every bit as complex as the wars fought between neighboring groups. Decades of research by primatologist Franz de Waal, studying both semi-wild and wild chimpanzees, revealed that an alpha male maintains his position not through brute strength alone, but through an intricate web of carefully cultivated alliances. He grooms potential rivals, creating what can only be described as social debt. He deliberately supports lower-ranking males during minor conflicts, investing in loyalty that may pay off months or years later. He displays aggression selectively, choosing moments that maximize political impact. And then, he waits. He waits until the reigning alpha becomes politically isolated, until key allies drift away or switch sides. Only then does he move to seize power. The defeated males rarely retire peacefully. They are harassed, driven to the margins of the community, and in some documented cases, killed by the very coalition that has just taken control. Within this calculated political system, chimpanzees display another ability that has led many researchers to use the word planning in its fullest cognitive sense. They remember individual relationships for years, and they modify their behavior towards specific individuals based on the history they share. A chimpanzee that has been wronged by another, even over something relatively minor, such as having food stolen or being pushed aside during grooming, does not simply forget. Long-term field observations have documented individuals behaving completely normally for hours, sometimes even days, before choosing exactly the right moment to retaliate against the individual that had harmed them. This is delayed, intentional retaliation, not an impulsive burst of anger. The pattern of alliances, political manipulation, and revenge described here is not a convenient narrative assembled from studies of social primates in general. It is the specific political structure documented at Gombe and numerous other long-term field sites by researchers who devoted entire careers to observing it. And it is directly tied to the Fission-Fusion Society we explored in Part 2. Because chimpanzees constantly split into small parties and reunite again, they possess the perfect social framework for launching small, covert raids. A tightly cohesive herd like elephants or buffalo simply cannot organize that kind of operation. In other words, the very social system that allows chimpanzees to distribute scarce food efficiently is the same system that makes organized warfare between neighboring communities logistically possible. Let's go back to Ham's photograph in 1961. A chimpanzee, its hands trembling while making the facial expression an entire nation mistook for a smile, had just completed a sequence of control tasks with such remarkable precision that NASA entrusted it with paving the way for America's first manned space missions. 48 years later, another pair of hands, trained not to pull control levers inside a spacecraft, but to hold a wine glass, type on a keyboard, and unlock doors in front of familiar visitors, tore apart a woman's face in just 12 minutes. These are not two unrelated stories about two different animals that happen to appear in the same documentary. They are two extremes of the very same nervous system. The same extraordinary manual dexterity, the finest found anywhere in the non-human primate world, guided by an impulse control system that is significantly weaker than that of its own closest living relative, the bonobo. As we explored in Part 3, we call chimpanzees our closest relatives, sharing nearly 99% of our DNA. We look into their expressive faces and see joy, curiosity, friendship, because, as we discussed in Part 1, the human brain is hardwired to recognize itself wherever it can, especially in a face that looks so remarkably like our own. But a percentage of shared DNA cannot tell you what is actually happening behind those eyes in a particular moment. It cannot tell you whether the smile in a photograph is genuine happiness, or a fear grimace, an expression of overwhelming distress mistaken for delight. It cannot tell you that the hands holding a cup of water are controlled by the very same neural circuitry that once shaped a twig into a termite fishing tool deep in the forests of Gombe, and, under different circumstances, may also have taken part in a silent border raid against a neighboring community. The next time you watch a video of a chimpanzee wearing a jacket, wearing a helmet, grinning broadly into the camera. Look at its hands before you look at its face. Because those hands, with all the precision, all the patience, and all the refinement that millions of years of evolution have invested in them, are nowhere near as innocent as the face above them wants you to believe. If this documentary has changed the way you see the animal we so casually call our closest relative, consider subscribing. The darkest things in nature are not always the ones with the biggest teeth or the sharpest claws. Sometimes, they are the creatures intelligent enough to know exactly how never to look suspicious.